While you're brewing your morning coffee somewhere in Shanghai, Tesla is building 3 complete electric cars, not assembling parts shipped from overseas, not bolting together thousands of components from dozens of suppliers, building from molten aluminum to a finished vehicle ready to drive off the lot. In less time than it takes you to make breakfast, Gigafactory Shanghai produces vehicles that traditional automakers need entire days to manufacture. This isn't just fast. This is a complete reimagination of how cars are made. Welcome inside the world's most efficient electric vehicle production facility, a place where the rules of traditional automotive manufacturing were thrown out the window and rebuilt from scratch. Gigafactory Shanghai isn't just Tesla's largest factory, it's the blueprint for the future of car manufacturing. With an annual capacity exceeding 750,000 vehicles, this facility cranks out more electric cars than most automakers produce across their entire global operations. But here's what makes this story absolutely mind-blowing. Tesla built this entire facility in just 168 working days. From breaking ground to rolling the first Model 3 off the assembly line took less than 1 year, and they did it for 65% less capital expenditure per unit of manufacturing capacity compared to Tesla's Model 3 production system in the United States. That's not an improvement, that's a revolution. Section 1, the Gigacasting Revolution. So let's start with what might be the single most transformative innovation in automotive manufacturing in the last 50 years. Gigacasting. Picture this, a machine the size of a small house weighing over 900,000 pounds, generating clamping force equivalent to 6,000 tons. And here's the kicker, this behemoth can create an entire section of your car in 80 seconds flat. Traditional car manufacturing works like this. Hundreds of individual metal parts are stamped separately, then welded together piece by dozens of robots over several hours. A typical rear underbody assembly for a conventional vehicle requires more than 70 separate stamped parts, hundreds of welds, multiple robots, extensive quality checks, and introduces dozens of potential failure points. It's complex, time-consuming, expensive, and leaves room for error at every single step. Tesla's gigacasting throws that entire process in the trash. The Giga press injects 176 pounds of molten aluminum, heated to a scorching 1,600 degrees Fahrenheit, into a massive mold at speeds reaching 22 miles per hour. The liquid metal fills every intricate detail of the mold in seconds, then solidifies under immense pressure. The result? One single perfectly formed aluminum casting that replaces those 70-plus traditional parts. Think about what this means. 70 individual parts means 70 different stamping operations, 70 different quality checks, hundreds of robotic welding operations, hundreds of fixtures and tools, and hundreds of opportunities for something to go wrong. Tesla eliminated all of that. One machine, one operation, one perfect part. And the numbers? They'll blow your mind. Gigacasting reduces production time by 40%. It cuts manufacturing costs by approximately 35%. It saves roughly 10% in weight compared to traditional welded assemblies. It improves structural rigidity because one solid piece is inherently stronger than dozens of pieces welded together. And it dramatically simplifies the supply chain because you're dealing with raw aluminum instead of managing dozens of different stamped components from multiple suppliers. The first Model Y vehicles to roll out of Gigafactory Shanghai with rear gigacastings marked a pivotal moment. This wasn't just an incremental improvement, it was proof that the fundamentals of car manufacturing could be completely reimagined. Section 2, the stamping powerhouse. Before gigacasting became widespread, the Model 3 relied heavily on another piece of absolutely remarkable equipment, the Schuler servo stamping press. And this machine is rarer than you might think. There are only 35 of these presses in automotive manufacturing worldwide. Tesla's was the first one ever installed in the United States. Giant rolls of high-strength steel arrive at the factory weighing thousands of pounds each. These coils are fed into the Schuler press, which can stamp a complete body panel every 6 seconds with incredible precision. The servo technology allows the press to control the speed and force at every point during the stamping operation, unlike traditional mechanical presses that operate at fixed speeds. This precision enables Tesla to create parts that were previously impossible. The Model 3 front fender has greater depth in a single piece of stamped steel than any other fender in production anywhere in the world. That deep, complex shape would require multiple pieces in traditional manufacturing, but the Schuler press forms it in one shot. Every 6 seconds, another perfect panel emerges from the press, ready for the next stage of production. These panels, hoods, doors, fenders, roof sections, move rapidly through the factory on automated conveyor systems. Hundreds of stamped parts per hour, flowing seamlessly into the body shop where the real magic happens. Section 3. Robotic Precision Welding. Step into the body shop at Gigafactory Shanghai, and you're stepping into the closest thing we have to the future. Picture rows of massive robotic arms, each weighing hundreds of pounds, moving in perfect synchronized choreography. Some facilities use a few dozen robots. Gigafactory Shanghai operates with 95% automation in the welding workshop, deploying more than 500 robotic arms in the first phase welding workshop alone. These aren't your typical industrial robots. They're programmed to work together with millisecond precision, each one aware of exactly where every other robot is at all times. 8 robots will simultaneously work on a single Model 3 body, welding, riveting, and bonding panels together at speeds the human eye can barely track. But here's where it gets really impressive: the quality control. Tesla deploys 47 specialized robots in scanning stations throughout the body line. These aren't welding or assembling anything, they're measuring. Every single Model 3 that moves down this line gets measured at 1,900 individual points. And we're not talking about rough measurements. These robots measure with a precision of 0.15 millimeters. That's about the thickness of 2 sheets of paper. Why does this matter? Because precision at this level means panel gaps are virtually non-existent. It means doors align perfectly. It means the vehicle structure is exactly as the engineers designed it, which translates directly to safety, aerodynamics, and that premium feel when you close the door. Traditional automakers rely heavily on human inspectors to check a few dozen critical points. Tesla's robots check 1,900 points on every single vehicle automatically, and it doesn't stop at dimensional accuracy. Every single bolt that gets fastened has its torque automatically measured and recorded. Too loose? The system catches it. Too tight? The system catches it. This creates a digital record for every vehicle that documents exactly how it was assembled. The welding workshop automation rate approaches 100%. Humans monitor, maintain, and troubleshoot, but the actual welding is performed entirely by machines working around the clock. The result is a body in white, and the industry term for the assembled body structure before paint, that's incredibly strong, remarkably light, and manufactured faster than traditional methods could ever achieve. Section 4. The paint shop. Once the body structure is complete, it enters one of the most sophisticated paint facilities in the automotive industry. The body gets thoroughly cleaned to remove every trace of oil, dust, and contaminants. Then comes the e-coat process. The entire body is submerged in an electrolyte bath that provides a robust layer of rust and corrosion protection. After the e-coat is baked on in heated ovens, robotic spray systems take over. These aren't simple spray guns. They're precision applicators that can control paint flow, atomization, and coverage with incredible accuracy. Multiple robots work simultaneously, each programmed to cover specific areas with perfect consistency. The automation here serves a critical purpose: absolute consistency. Human painters, no matter how skilled, introduce variation. One section might get slightly more paint than another. The temperature of the spray gun might fluctuate. Humidity affects the application. Robots eliminate these variables. Every vehicle gets exactly the same treatment, the same number of coats, the same thickness, the same curing time in the ovens. Tesla applies base coats, color coats, and clear coats in multiple layers. Each layer is baked in ovens to ensure proper adhesion and that signature glossy finish. The entire paint process is conducted in controlled environments with filtered air to prevent any dust or contaminants from ruining the finish. What emerges from the paint shop is a gleaming body, perfectly colored, protected against the elements, and ready for the final assembly stages. Section 5. Battery integration and the marriage. Now we get to one of the most critical and fascinating stages: battery integration and what the industry calls the marriage. This is where the upper body meets the lower body, where the drivetrain connects with the passenger compartment, where thousands of pounds of battery pack become one with the vehicle structure. The battery pack for a Model 3 is an engineering marvel on its own. It contains thousands of individual cylindrical battery cells arranged in modules, sophisticated thermal management systems to keep everything at optimal temperature, battery management electronics that monitor every single cell, and structural components that turn the pack into a load-bearing element of the vehicle. This pack weighs over 1,000 pounds and contains enough energy to power an average home for several days. Meanwhile, on parallel assembly lines, the drivetrain is being assembled. Electric motors that can spin at over 15,000 RPM, inverters that convert DC battery power to AC motor power, suspension components, cooling systems, and the rear gigacasting we talked about earlier all come together as one complete unit called the skateboard. Here's where the marriage happens. The painted body travels on one line while the skateboard travels on another. When they meet, precision robotic systems lower the body onto the skateboard. Dozens of connection points need to align perfectly. Electrical connectors must mate correctly. Cooling lines must connect without leaks. Mounting points must line up to within fractions of a millimeter. The marriage process at Gigafactory Shanghai takes approximately 1 minute and 40 seconds per vehicle. Think about that. In less than 2 minutes, 2 major assemblies, representing thousands of individual components, are joined together to create a functional vehicle platform. Automated systems then secure everything with precisely torqued bolts. Every connection is tested. Every electrical system is checked. The vehicle that was 2 separate assemblies seconds ago is now one integrated machine. Section 6. Final assembly. After the marriage, the vehicle enters final assembly, where it transforms from a rolling platform into a complete car. This is where humans and robots work together most closely. Massive robotic arms install the front and rear seats with perfect positioning. The dashboard assembly, complete with the touchscreen, instrument panel, and all electrical connections, gets integrated. Miles of wiring harnesses snake through the interior, connecting hundreds of sensors, cameras, and computers. The panoramic glass roof is carefully positioned and sealed. Doors are hung and aligned. The frunk and trunk are fitted. Wheels and tires are mounted and torqued to specification. Every 30 to 40 seconds, another completed Model Y rolls off the line at Gigafactory Shanghai. For the Model 3, the cycle time is slightly longer, but still remarkably fast. Approximately 44 seconds per vehicle at peak production. That means the final assembly workshop completes a car faster than most people can parallel park. The factory operates with such efficiency that made-in-China content has increased from just 30% when production started in late 2019 to approaching 100% today. Initially, Tesla had to ship many components from the United States. Now, a sophisticated network of Chinese suppliers provides everything from battery cells to interior trim, dramatically reducing costs and complexity. Section 7. Quality control and testing. But Tesla doesn't just build cars fast, they build them right. The quality control process at Gigafactory Shanghai operates at 3 distinct levels. The first team inspects the body in white before paint. They're looking for weld quality, structural integrity, and dimensional accuracy. The second team inspects after paint, checking for finish quality, color consistency, and surface imperfections. The third team performs final quality checks after complete assembly. AI-powered vision systems inspect 95% of vehicles post-assembly, detecting defects as small as 0.1 millimeters in paint and panel gaps. These computer vision systems can spot issues that human inspectors might miss. Tiny scratches, microscopic paint defects, slight variations in panel alignment. Tesla's goal? Zero defect tolerance. Every vehicle undergoes comprehensive testing. The infotainment system boots into factory mode where technicians verify every function. All 8 cameras for the autopilot system are tested and calibrated. The climate control system runs through full cycles. Every light, every switch, every motor is checked. The charging port opens and closes. The power liftgate operates. The seats adjust through their full range of motion. Then comes the dynamic testing. The vehicle is driven onto a dynamometer, where the wheels spin at highway speeds while the car remains stationary. This tests the electric motors, the regenerative braking, the battery management system, and the overall drivetrain under load. Finally, each vehicle gets a road test. Real driving conditions, acceleration, braking, handling, noise levels, all evaluated by trained drivers who've tested thousands of Teslas and know exactly what's normal and what's not. Section 8. The numbers that changed everything. Let's talk about the numbers that make Gigafactory Shanghai such a game changer for the entire automotive industry. The facility spans over 860,000 square meters. That's roughly equivalent to 150 football fields of manufacturing space. At full capacity, it can produce over 750,000 vehicles annually. To put that in perspective, that's more than many legacy automakers produce globally across all their plants combined. The capital expenditure efficiency is staggering. Tesla spent approximately $2 billion building Gigafactory Shanghai. That 65% reduction in capital costs per unit of manufacturing capacity compared to the Fremont facility in California means Tesla can build the same production capacity for about 1/3 the cost. For a company trying to accelerate the world's transition to sustainable energy, being able to build factories more cheaply means being able to scale faster. The speed? It's something traditional automakers are still struggling to comprehend. From raw aluminum coils entering the stamping press to a finished vehicle driving out the door takes approximately 24 hours. Some sources report the pure manufacturing time, excluding curing and cooling periods, at under 40 seconds per vehicle for certain models. At peak efficiency during late 2022 and early 2023, Gigafactory Shanghai was producing approximately 3,000 vehicles per day. In 2021, Tesla exported 155,000 vehicles from Gigafactory Shanghai. That represented half of all new energy vehicles exported from China that year. The factory became Tesla's primary export hub, shipping Model 3 and Model Y vehicles to markets across Europe, Asia, Australia, and beyond. By December 2025, Gigafactory Shanghai reached another milestone: 4 million vehicles produced. The pace from 3 million to 4 million took approximately 410 days, demonstrating sustained high-volume production that few facilities in the world can match. Section 9. The Ripple Effect. Gigafactory. Shanghai didn't just change how Tesla builds cars. It changed the entire Chinese automotive supply chain and sent shockwaves through the global auto industry. When Tesla first opened the factory, only about 30% of components were sourced locally. Tesla worked intensively with Chinese suppliers to meet their quality standards and production requirements. Companies like CATL for battery cells, Zhejiang Sanhua for thermal management components, and dozens of others stepped up their capabilities to become Tesla suppliers. The result? A rising tide that lifted an entire industry. Chinese EV makers watched Tesla's manufacturing techniques closely. The giga casting technology? Chinese companies like Xpeng are now developing their own versions, with casting machines approaching 16,000 tons of clamping force. The automated production techniques? They're being adopted across Chinese automotive manufacturing. The vertical integration strategy? It's becoming the new normal. Tesla's approach essentially did for Chinese EV manufacturing what Apple did for Chinese smartphone manufacturing. It brought world-class processes, pushed suppliers to achieve higher quality, and created an ecosystem of capable companies that could then apply those learnings to their own products. Legacy automakers took notice too. The speed of construction, less than a year from groundbreaking to production, showed what's possible when regulatory approvals are streamlined and construction moves at maximum pace. The production efficiency demonstrated that the old ways of building cars were no longer competitive. Section 10. What this means for the future. Gigafactory Shanghai represents more than just one very efficient factory. It's a template. Tesla has applied lessons learned in Shanghai to Gigafactory Berlin in Germany and Gigafactory Texas in Austin. Each successive factory has been built faster, more efficiently, and with greater production capacity than the last. The machine that builds the machine, Elon Musk's term for the factory itself as a product, continues to evolve. The newest innovations include vertical production lines where two assembly processes stack on top of each other, saving nearly 100 meters of factory floor space. Automated guided vehicles, small robots that transport parts throughout the facility, eliminate the need for traditional conveyor systems in some areas. AI-driven quality control systems that learn and improve over time, getting better at detecting potential issues before they become actual defects. The ultimate goal? A factory that can produce a vehicle every 10 seconds. Tesla's next-generation vehicle platform, currently in development, aims to use the unboxed manufacturing process, where major sub-assemblies are built in parallel and then connected at the very end. This could potentially double production speed while halving manufacturing costs yet again. For the Model 3 and Model Y, continuous improvements keep pushing efficiency higher. Small changes, a slightly faster robot motion here, a simplified assembly step there, better logistics flow reducing waiting time, compound over thousands of vehicles per week into massive productivity gains. From molten aluminum poured at 1,600 degrees to a completed electric vehicle ready for delivery. From 70 individual stamped parts welded together to one single gigacasted piece. From weeks of assembly time to 24 hours from start to finish. Gigafactory Shanghai isn't just building cars, it's rewriting the rules of manufacturing. This is what happens when you question every assumption about how things have always been done, when you're willing to invest in massive automation, when you optimize for the factory as a product itself, not just the cars it produces. The result is a facility producing 750,000 vehicles annually, with quality that meets or exceeds traditional manufacturers, while doing it for dramatically less cost and in far less time. So the next time you see a Tesla Model 3 driving past, remember what went into building it. Remember those 47 robots measuring 1,900 points with 0.15 millimeter precision. Remember that 176-pound shot of molten aluminum forming an entire car section in 80 seconds. Remember the marriage happening every 100 seconds, joining thousands of components into one seamless machine. But here's my question for you. If Tesla can build a factory this efficient in just 168 working days and produce cars at costs 65% lower than traditional methods, what does this mean for every other manufacturer still building cars the old way? Drop your thoughts in the comments below. If this deep dive into manufacturing innovation blew your mind like it did mine, smash that like button. Share this with anyone who thinks traditional automakers can keep up with Tesla's pace. And subscribe because we're just getting started exploring the technology that's transforming our world. The future isn't coming, it's already here, being built every 30 seconds in Shanghai.